Okay, so the situation is that a person is standing up here at point D on a mesa, which is a high plain, and there's a fire which first has an angle of depression of 11.39 degrees, and then the angle of depression as the fire spreads from point A to point B becomes 13.57 degrees. The height of the mesa is 3,400 feet, and we're trying to find based on that information, what is the speed at which the fire is traveling. Now, to get the speed from point A to point B, we're going to use the distance equals rate times time, which is speed times time formula. So, we're going to find the speed r. We know that we're given that the time is 3 minutes. So we have the time. We need to find the speed. So in order to employ this formula, we need one more known, which is this distance here. And we're going to call that distance in our solution AB, distance AB. So in order to calculate the speed that the fire is traveling, we need to find the distance AB. Now, in order to find the distance AB, we're going to find the distance AC and the distance BC, and we're going to subtract the distance BC from the distance AC to get the distance AB. So one step at a time, let's start by finding AC, length AC. So we're going to find length AC. To find length AC, we first need angle ADC. So we're going to start, in order to find AC, we need to first find angle ADC. We always put ADC means that D is actually the angle, but it's the angle subtended by A and C. Okay, so angle ADC we need to find. Now we have that this whole part here, this is important, this whole part is 90 degrees. So to get angle ADC, which is this angle here, ADC, subtended by A and C, we need to go the full 90 degree angle minus 11.39 degrees, and we get 78.61 degrees. So that is angle ADC, which we're going to use to find side AC. Side AC is opposite angle 78.61, angle ADC. We have the adjacent to that angle, so we're going to use the tangent. Tangent, remember, of an angle is equal to the opposite over the adjacent. In this case, the tangent of 78.61 is equal to the opposite, which in our case is AC, over the adjacent, which is 3,400. Okay, so we have tangent 78.61 degrees, which is angle ADC, that's this angle here, is equal to the length AC, which we're trying to find, over 3,400. That's tangent of an angle is equal to opposite over hypotenuse. Now we solve for AC. We just cross multiply. So AC, sorry, not cross multiply. We're going to multiply 3,400 times the tangent of 78.61 to get AC. So AC equals 3,400 times the tangent of 78.61. And that comes out to be 16,877.32 feet. 16,877.32 feet. So that's the length of AC from point A to point C. So let's box that in. Okay, because we're going to need that information. Remember, we're trying to find the speed that the fire is traveling from point A to point B. So in order to do that, we need this length, AB. Now, to find length AB, we need still length BC. So to find BC, we do a similar process that we did to find AC. First, we need angle BDC. So the angle subtended, the angle at D subtended by B and C. So we need BDC. Angle BDC is equal to the 90-degree angle, that whole corner, minus the 90-degree angle, minus the 13.57 degrees. That will give us this little piece here. If we take this piece out here, we'll be left with this little piece here, which is what we want. And that's equal to 76.43 degrees. Tangent of 76.43 degrees, since this is now our reference angle, this is the side we're looking for, BC. BC is opposite that angle, so opposite over the adjacent, which again is 3,400 feet. To solve for BC, we multiply both sides by 3,400, and we get BC is equal to 3,400 times the tangent. There's not enough room here. So we're going to go 3,400. We're going to go BC is equal to 3,400 times the tangent of 76.43 degrees. So BC is equal to 14,086.182 feet. So we found this distance right here. This distance is 14,086.182 feet. That's right here. Okay, and we know that this whole distance, AC, is 16,877.32 feet. So now we have what we need to find AB, where our goal was to get the distance the fire traveled and use the time of 3 minutes in order to find the speed using the distance equals speed times time formula. So in order to find AB, we're going to subtract the smaller distance, 14,086.182 feet, from the larger distance, 16,877.32 feet. So AB, distance AB, is equal to the distance AC minus the distance BC. We found that the distance AC is 16,877.32 feet, and the distance BC is 14,086.187 feet. And that difference is 2,791.138 feet, which is approximately, to 2 decimal places, 2,791.14 feet. So now finally we have this distance here, which we found to be 2791.14 feet. That is the distance that the fire traveled. Now we're asked to find the speed that the fire travels, the 2,791.14 feet, in miles per hour. So first we have to convert that distance to miles, and then we have to convert the 3 minutes to hours. Once we do that, we can use the distance formula, distance equals speed times time, to find the speed. So to do the conversion, hopefully you understand this way the easiest. We have this many feet out of a total of, there's a total of, there's a total of 5,280 feet in 1 mile. So if we do that division, 2,791.14 divided by 5,280, we get 0.5286 of a mile. So this part here is 1 mile. So the numerator here is that part out of a whole, that part of a mile. Okay, so this is really this many. Could write it this way: this many miles. Okay, because this is 1 mile. So this is the part out of 1 mile, and that part is about a half of a mile. Similarly, we've got 3 minutes out of 60 minutes, so it's 3/60th of an hour, which is 0.05 hours. So now in the last step, we take our distance equals rate times formula. That's normally the form that we remember the formula, where rate is the speed. Divide both sides of that formula by time, by t, and you'll get a formula for speed for rate. Rate is distance over time, d over t. And we found that the distance is 0.5286. Remember, that was miles. We converted that. And the time was 0.05 hours. We also converted that. That's how much 3 minutes is. And we plug it into the formula. Rate or speed equals 0.5286 over 0.05, and we get this speed equals 10.572, and that is approximately equal to 10.6, and that's miles per hour. That's the speed, miles per hour. So it's approximately equal to, that's the answer you should find in the view an example. Okay, so 10.6 miles per hour. The speed is approximately 10.6 miles per hour. That's the answer to the problem. That's how fast it takes the fire to move from point A to point B.